Good afternoon, ladies and gentlemen. Welcome to today's Open Classroom webinar from a warm Cape Town. I trust everyone is safe and well. Today's webinar is officially webinar 61 in our Open Classroom series, which began at the beginning of April last year. Please find video copies of the last 60 webinars on our website under the Services pull-down menu in the webinar section, as well as around 300 FAQ videos which we've created from the webinar series, except these are searchable. Please also refer to our BIM webpage for more information with regards to Civil Designer's capabilities to contribute to any BIM workflow process via the open format Building Smart IFC file types. What sets Civil Designer apart is its ability to customize the data extents, i.e. road length, and coordinate system of our IFC output. Back to today's webinar, where we welcome back Cameron Boyle, who many of you in Gauteng will know well. During Cameron's presentation today, please feel free to use the text chat service on your GoToWebinar app or webpage to ask us any questions you may have during his presentation. After today's webinar, we'll post a video copy on our website in the webinar section. So, good afternoon again, Cameron, and please take it away.
Thank you, Charles, and welcome everybody to today's road webinar. I'm excited to show you the powerful point control functionality. Simply put, point control is a point that is indicated in the cross-section of your road template. You are then able to modify that point horizontally and or vertically, targeting a CAD entity or an existing road string. This then allows the location of the cross-sectional point to be moved as per your rules specified. In front of us, I have a project that we are going to use as a support showcase project, where some of our clients have asked for assistance on how to align your road batter layer with an existing retaining wall. That is the objective today, but before we get to this point, I need to show you the basics of your point control. So I'm going to start with this project. Inside this project, I'm going to show you how to use the point control, and by doing this, we're then going to extend the sidewalk, put in your compulsory V-drain and footpath, and then end off with specifying your batter. Before you use the point control functionality, you need to go and specify your point controls within your template. Go into Tools, Template Paths, and specifying which template we want to work with. It may be that you've already got a template that you want to use these point controls on. So in that case, it's quite easy to take an existing edge and edit it. You'll see that there's an option there of point control name. Let's go and call this right point control number 1. Once you've inserted that name, you'll also find that if you go to the data page, that point control name is inserted automatically. Looking on the left compulsory, I'm going to go and add some additional information. I'm inserting an additional horizontal movement of 1 meter, a vertical movement going down, so 0.005, and I'm then going to call this left compulsory. Click on the green tick, escape, and then go and insert a V-drain. I've already gone and worked with a couple of these components, so if I go to the template option, these are the components I've worked with. You can then go and right-click and add to template. Then moving on to my left cut, I'm then going to select a paved footpath. Again, right-click and select Add to Template. In addition to that, I'm then going to put in a border after my footpath, looking at 100 mils horizontal, and then vertically I'm going to make that flat. I'm going to give this a point control name of left footpath. Click on the green tick. Then moving on to the left fill, same thing here. When I go and select this, you can see that the component preview It's quite different to what we had with the cut. So I'm going to go and right click, go and select edit. In this case, go and change the texture to cobblestone. These textures already have their own pen colors, so it doesn't matter what color you specify over here. Click on close, save it, and then add it to my left fill condition. Again, go and add the additional 100mm border. Pressing escape. So to recap what we've done here, if we look at the left compulsory, and then looking at the left cut, as well as the left fill, and take note I've used the same code irrespective of whether I'm in cut or fill for my footpath. I'm then going to go and save this as a different template. And then attach it to my project. When we use the point control functionality, I'm then going to go and use a CAD polyline. Before I use that function, I'm going to turn on the CAD polyline. And then going to alignment, regression, and in 8.4 you'll see there's a function there called point control rules. When you use this function, you have the option of selecting a target. If I go and left click over there, as you move your cursor, you'll see that the different options become highlighted. If I select a road string, you can see in your prompt area, you can go and specify which road string you want to associate this point control with. Back to the function, looking at what options we've got here. The first point we went and put in was left compulsory point. You can then go and specify if you want to apply it to all your templates or only a specific template, in our case, bus lay-by. You can also then go and turn it on and off so you can run different scenarios and see how it reacts. Looking at the mode, you can go and apply a horizontal, vertical, in this case, both. So the horizontal and the vertical offsets will be based on the following. Looking at our height options, I go and left click, brings up this dialog. You can go and specify if you want this point to be all at a fixed elevation. If you want to pick up the elevations from, let's say, your entities, and in this case, we're picking it up from the polyline I've just pointed out, you have the option to interpolate the point from a DTM surface, and I'll do this at a later stage. Else to go and retain a grade. And if you go and select retain grade, it picks up the grade from what you've specified in your road template. And with some of these functions, you also have the option to go and add a constant height. Selecting from entities, in this case, clicking on OK. Click on select target, and then go and specify where you want to associate your point control from. Clicking on the polyline, Civil Designer would then pick up the start and the end chainage, which you could leave as is. Alternatively, you can go and customize your own chainage range. Giving it a description, and clicking on OK. In earlier versions of using the point control functionality, you would have to go and redesign the entire road besides the horizontal alignment. In the latest point control functionality, you no longer have to do that. If I go to alignment and I go to road recalculate settings, I only now have to apply the road template. So every time I go and select this icon, I'm only applying the road template. Click on OK, and then selecting that icon. As we can see, it's been updated. Let's go and view this in 3D. Changing my zoom view. Let's recap on what we've just done. We used the polyline and we associated this left compulsory point with our point control that we inserted. We then went and put in the V-drain, we put in the additional sidewalk width, and then I also went and put in a 100 mil border on the edge there that I'll use at a later stage. Also take note of the grade of our V-drain. It's all draining down towards our junction. I'm going to go and change that. I'm going to make the middle of our bus lay-by the lowest point of our V-drain, and the emphasis there being that your V-drain doesn't necessarily have to follow the grade of your road vertical alignment. Escaping the render view. And then selecting the polyline. You can see we currently have 4 vertices on our polyline. I'm then going to go and insert an additional one and make that the lowest point. With the polyline selected, I go and right click and go and select Insert Vertex. Go and specify your insertion point. Right click and quit. And then looking at the properties of the polyline, changing the elevation of vertex number 3. I've previously gone and calculated an appropriate elevation, making it the lowest point in the V-drain. Selecting the next vertex and changing the elevation appropriately. In order to update the information that we gain from the polyline, again I go and select the recalculate icon. Then taking full advantage of our 3D view, let's go and see what the update looks like. There you can see where the lowest point is, where you'd preferably want to go and put in a stormwater drain. If you'd like to go and view this all in a cross-sectional format, before doing so, let's pan a bit so that we can see the cross-section as well as the plan view. Going back to Section, Graphical Edit. Let's move that out of the way. So looking at the position of my cursor, we can see as I go and press page down that the height of the V-drain drops to approximately over there, which would then be the lowest point, and then heading back up. In this example, we used a polyline for our point control, but you also have the option of using a spline. Let's look at that in more detail. I'm then go back to the CAD mode and draw in a spline. This spline will later on be used to customize my embankment. Going back to the point control functionality, so we go and select the roads mode, go back to alignment regression, point control rules. If you recall, when we specified our point controls, we also went and specified a left footpath. Again, I'm then going to specify which template to use the point control on. As far as the height is concerned, I'm going to pick up the elevation from my ground. And in that case, we're looking at merged ground surface with a search distance of 30 meters in my survey. And then I'm going to go and add a constant of 100 mils so that you can see what that looks like. Not to forget that currently our V-drain elevation was changed according to the polyline. So I'm going to take that back to retain grade. Select target, clicking on the spline and giving it a description. recalculate, and the design is updated. The different colors indicating whether you're in cut and fill. Again, let's go and view that in the render view. You can see the additional embankment that we've gone and drawn in with the 100 mil step. If you do go and make changes to your CAD layers, you'll see that your point control would dynamically be updated. And something else worthwhile mentioning, if I go and select a CAD layer that we used during the point control process, if I were to go back to alignment regression, point control rules, you can see that the color has changed because it's no longer an option. Now that we've learned the basics or the foundation of how point control works, let's go and apply it to our support showcase project. Looking at what we have in front of us, I'm going to section, graphical edit. As our road is coming from the top down towards the bottom, the left-hand side is actually this blue embankment. And what I've done beforehand is I've gone to my display settings and I've turned on the cut fill indicator. Let's use 7 meters. Where our shoulder breakpoint is higher than 7 meters, we want to apply a retaining wall. Again, what I've done beforehand is I've gone and created a cross-sectional symbol. The default symbol file can be found in this directory. I went and created an additional symbol called retaining wall. Clicking on OK, and then using that for explanation purposes. So in this example, what we want to do is we want to take the batter layer and align it up with our retaining wall. Now, that could be an existing retaining wall. It could be a retaining wall whose offset differs from the road, and its height would also then go and change. So I'll run you through the different scenarios using the point control functionality. Closing our cross-section, going back to our template, selecting template path. And then go and right-click on the existing template and go and make changes to it using the point controls. In our example, we're looking at left fill, anything greater than 7 meters of fill. Currently, that's all we got at this stage. So I'm going to go and add additional information. Going to select Add Edge, specifying a horizontal distance of 0.75 using the cross-fall grade of our carriageway. In addition to that, I'm then going to put in 1.5 meter horizontal and a vertical movement of -1. This time I'm then going to specify the point control name as retention top. That would then be the top position of our retaining wall. Thereafter, I'm then to put in horizontal movement of 0 and a vertical movement. And this is really just for explanation purposes, -2. That vertical movement will change depending on the amount of fill we have in our project. And then go and call this retention bottom. And escaping. For the retention wall, I've gone and created something specific for this project for a reason. Now, if I go and place this, you'll see that it looks like it's inverted, and I've left it like that for a reason so I can explain to you. It may be that you're in the same situation and it looks inverted. I'll show you how you can fix that. Because I've associated to the template, I can then go to the template option. There's all the components associated with the template, and we're looking at this specific one. Once you've selected it, you can then go and right click and go and select edit. Very important is whatever you go and specify in this first row, that is where the hook point is for your batter layer. So our batter is going to intersect our retaining wall at that point. Then looking at these special vertical movement codes, our retaining wall is going to be worked from the top down to the bottom. If you are happy with that, then you make this special code a positive sign. If you make it a negative sign, it means that you're inverting the direction. Now, don't worry about the display being updated. We aren't quite finished with the current component just yet. Scrolling down, same thing in this case. We're looking at the highlighted edge here, and we're going from the last cell. From here, we want to go back up. So in that case, we go and make that a negative value. And finally, the last thing you need to do is go and right click and select preview infill. And not to forget, you can also go and specify which texture you would like to use. Let's go and close that and save it. You can then go and save this as another particular template, not to override the original one. Let's go and close that. Don't forget to associate the new template with your road design. Looking at batter to retain as our template path name. Now that we've done the templates, let's go to our point control rules. Looking at the retention top. Now, if you recall, we went and set up the control name inside our template. So there you can see the position of our retention top and our retention bottom. And here we're specifying where that position must be. The retention top, again, we'd only apply it to our batter to retaining wall template, switch it on and off, specify if you want horizontal, vertical, or both, and then go and specify the height options. In this case, I'm going to go and select retain grade. If you don't quite recall which grade I'm referring to, bring in that screen grab back, and then just moving this to that position there. So the grade will be picked up from the specified horizontal and vertical movement specified in your template. That equates to 66.67% grade. Clicking on OK. Selecting the appropriate target. And in this case, we've got a two-dimensional polyline. Looking at the retention bottom, specifying our template name again. We're looking at both the horizontal and the vertical. This time, we want to pick up the bottom of the retaining wall from our survey, which is on surface 1, original ground, specify search distance, and clicking on OK. Again, specifying which target you want to use, and we're using the same polyline. Click on OK and recalculate. Let's go and see the result in 3D. selecting my defined zoom views, and then just zooming into the retaining wall. Let's take a look at what it looks like in a cross-sectional format. Going to Section, Graphical Edit, specifying where you want the cross-section, and then just zooming in there. The emphasis being on the grade that we retained from the template. So if I were to go and right-click there, go and select Measure, place my cursor close to that point, go and press J, Enter, go to that point, J, Enter, and then just check in that your grade and your slope is correct. You may be asking yourself, what if your retaining wall isn't at a fixed offset from your road? What happens if that offset differs? And it could be that in a real project situation, the retaining wall has different heights. I'm going to go and close the cross section and look at alternative design scenarios. If we were to go and select the polyline and go and move it so the offset isn't fixed, and then also go to my point control rules and specify a different top height. For explanation purposes, let's go and say that we want the top of the retaining wall to be interpolated from the ground level. And in addition to that, we want to go and add a constant of, let's say, 7 meters. So not only have I changed the offset, but I've also then gone and changed the elevation of the retaining wall on the top. Recalculating. Going back to the cross-section option. You can see the offset as well as our elevations have been updated. So if I were to go back to that original point, go and measure from that point to this point, you'll see then that your slope and your grade has changed. To finish off, just looking at the difference to what we previously had and how everything has easily been updated. Charles, I think my job here is done. Thanks everybody for joining us. Please let us know if you've got any additional questions. Until next time, cheers for now.
Wow, Cameron, thank you very much. That was awesome. And thank you very much to all of you who attended today's webinar. Please remember, if you would like any further information with regards to Civil Designer, or if you'd like to request future webinar topics, as was today's case, please use the email listed on your screens right now. Once again, thank you for your time. Have a great afternoon, weekend, and goodbye for now.